Hi guys, so in this video we're going to be going over the use of trigonometric identities in order to solve equations with trigonometry. So in the last video we covered some of the trigonometric identities that you will be given and that you will be expected to remember. And in this video we're going to be showing how we can use them to solve these equations. So in this one we're asked to show that sine x tan x plus cos x is equal to secant x. So we know that secant x is equal to the 1 over the cosine of x. And tan x is equal to sine x over cos x. I think it's just really important to remember that when you have sine x and cos x in there, making tan x into sine x over cos x just makes it a lot easier because we're just working with two different functions of trigonometry. So if we substitute these into our equation, we get sine x times sine x over cos x plus cos x. So actually, since we're proving it, we don't want to put equals secant of x. We want to stick with the left-hand side and show that this left-hand side, LHS, I'm going to denote the S and RHS, we have to show that the left-hand side is equal to RHS, which is secant of x. So if we simplify this further, we get sine squared x over cos x plus cos x. And if we remember, the sine squared x is just the same as sine x to the power of 2. Okay, so we can move forward. Now what we want to do is get it into a common denominator, because as we can see, we have one fraction, we have another term independent of the fraction. We can make it one fraction by just multiplying this by cosine of x. We also have to realize that if we do so, we have a denominator of cosine x common, and secant x is equal to 1 over the cosine of x. So we want to get something in that form. So we get sine squared x plus cosine squared x over cos x. Now, the other one we're going to have to remember is that sine squared x plus cosine squared x is actually equal to 1, and we proved that in the last video. So we can just cross that and write as 1. So this is equal to 1 over cos x. And we know that 1 over cos x is equal to secant x. So it's equal to the right-hand side as required. Alright, so now if we move on to the next part. So hence solve the equation sine theta over 2 tan theta over 2 plus cosine theta over 2 is equal to 4 for 0 to theta to 4 pi, where theta is in radians. So we just proved that sine x tan x plus cos x is equal to secant x. So if we look at this part over here, this part is literally in that form except x is equal to theta over 2. So what we can say is that with x equals theta over 2, secant of theta over 2 is equal to 4. So that means that 1 over the cosine of theta over 2 is equal to 4. Cosine theta over 2 is equal to 1 over 4. And now we can use the inverse of cosine. So cos negative 1 of 1 over 4 will give us theta over 2. And if we look over here, it's in radians, because 4 pi represents the radians. So what we're going to do is get our calculator out. So the inverse of cosine of 1 over 4 is equal to theta over 2 is equal to 1.32 approximately. So therefore, theta is equal to 1.32 times 2, which is about 2.64. Now, there are other solutions to this. Remember that if we go the other way in the unit circle, so if we just look at the quadrants for 1 second, we have cost, so sine positive in this one, all of them positive in this one, cosine is positive in that one, tangent is positive in that one. Well, we just took the first solution that we got, which was in the all of them section. Now, if we subtract 2 pi from 1.32, we'll get the one in the fourth quadrant here. So theta over 2 is also equal to 2 pi minus 1.32, which is equal to, let's put in my calculator, 4.96. So theta is equal to 4.96 times 2, which is equal to 9.93. because it was not 4.96 exactly. That's why I rounded up one more. So we now have to also check that our range we're keeping within. So it's saying between 0 and 4 pi. And 4 pi, if we put into our calculator, is the same as 12.6. Right now, all these values are within that range, but we just have to make sure that they don't go over. So there are actually more solutions we can check just to see if there are any more that we're leaving out. So if we added 2 pi to our first solution, we'd go back. We'd go around the circle once and then go back. So 2 pi plus 1.32 is equal to theta over 2. So theta is equal to, let's just put that in. So theta is equal to 15.21. However, this one is wrong because this one is over our boundary of 4 pi. So therefore, the answers are theta is 2.64 and theta is 9.93. Okay, so to solidify our understanding, we're going to do one last problem. So we have to solve the equation cosecant squared theta plus 2 cotangent squared theta is equal to 2 cotangent theta plus 9, where theta is in radians and theta is larger than negative pi over 2, but less than pi over 2. So first thing we have to realize is that the cotangent appears in 2 different places, but then we have cosecant. And what we want to do is try and write this all in terms of the same trig functions. So what we have to do is figure out how to write cosecant squared theta in terms of cotangent. And thankfully, you are given an identity that links the two. So the identity is cosecant squared theta is equal to 1 plus cotangent squared theta. And the AdMath syllabus expects you to be able to make that connection, so make sure that you're constantly looking out for these things. So if we substitute that into our equation, we get 1 plus cotangent squared theta plus 2 cot squared theta is equal to 2 cot theta plus 9. And if we rearrange, we get 3 cot squared theta minus 2 cot theta minus 8 is equal to 0. And we can now factor because we have a quadratic. If we want to make it easier to factor, we could just say let x equal cot theta, and then it becomes a much easier quadratic to work with. Okay, so now let's factor this out. So we have minus 2 plus 4 is equal to 0. So x is equal to negative 4 over 3, and it's equal to 2. Now we need to substitute cotangent of theta back in, so cot theta is equal to 2, which means that 1 over tan theta is equal to 2. So tan theta is equal to half. And now we have to solve from there. So theta is equal to the inverse of tan of half, which is equal to, and we put it in the calculator. And remember, we're looking at radians, so make sure your calculator is in radians. So inverse of tan of half is equal to 0.464 radians, and we can denote that with the C at the top. That denotes radians. And we've still got a few more solutions because it's in between negative pi over 2 and pi over 2. So what we could do is look at the other side, the inverse of tangent of this solution here. So we got cot theta is equal to negative 4 over 3. So 1 over tan theta is equal to negative 4 over 3. So tan theta is equal to negative 3 over 4, and theta is equal to the inverse of tangent of negative 3 over 4. If we put that into our calculator, we get, let's just put that in, negative 3 over 4. That gives us negative 0.644 radians. And if you want to check that it's in our range, so pi over 2 is 1.57 and negative pi over 2 is negative 1.57, and these two solutions are both within that range. So therefore, our solutions to this equation are theta is 0.464 and negative 0.644 radians.